So hello everyone. Today we will be starting with Stat 2, Week 2 and 3. Greetings to all. So let's start the topic today. First one is frequency. Frequency is nothing but the number of time an element occurs in a data set. And second one is relative frequency. That is the frequency of an element divided by total frequency. It is mainly useful when the data set is in tabular manner. For example, take this data set, and when we draw a table of it, first column will represent the element, and second one will be that is the frequency. So element is a variable and f is a variable. We can call it as the variables, and 1 and 4 are the cases, like we saw in the case versus variable in week 1. So in the element there are several elements in the data set, like c, for 1 there is a 1, for 2 there is a 2. So we constructed a table for this data set, and we saw how many times 1 occurring in this table. So see, 1 2 3 4, 1 is occurring 4 times, so its frequency will be 4. Same for every element, 2 occurs 3 times. And similarly we calculated this, we added up all these frequencies, and we got the total frequencies to be 15. So now we know that the frequency of 6 is also 6 in this case, and we want to calculate the relative frequency of 6. It will be easier, like the frequency of 6 is 6 divided by the total frequency. Total frequency is 15, as we added up all the frequency. So 16 by 5 will be the relative frequency of 6. Now we will be looking at some important terms. For example, in this table, the first one is class interval. The lower part will be the LC, or the lower class limit. The upper part will be the UC, or lower one will be lower class limit, or LC, and the upper one will be upper class limit, or UC. It is generally represented for the continuous data set, as there are infinite values in the continuous data. In the numerical we saw in the week 1, in numerical data was further divided into discrete and continuous. For the continuous data set, as they are infinite elements, so we divided the element into various intervals. So the first interval is 10 to 20. If for let's see, for the second interval 20 to 30, the LC is the least class limit. In this case it will be 20, and the upper class limit for this case will be 30. So actually it is a wrong for this. It should be upper class limit should be 30 and lower class limit should be 20. The vice versa was true. And then the class width, also known as the class size, it a difference between the upper count and the lower count. This gives the distance between the two, or the size of this interval. So to find the size of the interval, we can simply minus the upper minus lower. So it will be in this case 10. And for class mark generally represent the average marks. For example, for this class, what will be the average number? So we take the lower class and upper class, then divide by 2, we get the average to be 25 in this case. So these are the terms, and it is a method to calculate various things. Like if we perform any statistical analysis, we can perform stat on discrete data only. On the continuous data, as they are infinite data sets, so we cannot perform any analysis on the continuous data, right? So we take a class interval in that case, and then convert them into a class mark comes out to be a discrete value. So we do not have to deal with infinite values now. We will take the class interval equal to the class mark in this case, and perform the statistical analysis which we want further, that we will be seeing in the later weeks. So note, for the class interval 10 to 20, see, for 10 to 20, the 20 is the upper class limit and lower class limit is 10. 10 is included in this class interval only, but 20 is excluded from this interval. It is written in this interval, but it will not be included in this interval. The reason for it is because, consider this in the following example shown in the above table: 0 to 10, 10 to 20, and 20 to 30. If we include both of them, 0 and 10, so see, 10 will occur two times, right, in the upper class limit of first one and the lower class limit of second one. So to avoid that, we exclude the upper class limit and take only the lower one. So 10 will be excluded from the first case but will be taken care of in the second case, as it is a lower class for the second case. So that's why if we do not want any element to be added or subtracted two times, so to avoid that case, we exclude the element of the upper class. Now we will be looking at the stem leaf diagram. It is a method, actually it is a way to represent a data in a sorted or ascending order. In a sorted order mainly, it can be ascending or descending. Mainly it is ascending, but the major portion which we need to focus is the it should be sorted, and this is the major purpose of this stem leaf diagram. So see, for a data given in a stem plot, we can conclude our data from this template to a numerical one by simple by using a simple method. See, first one is stem and they are its leaf, so we can simply say 1 0, that will be 10, 1 2, that will be 12, 1 4, that will be 14. So we have written the three. Then we will move towards the next step: 2 7 27, 2 9 29. Then we return the both of them. Then we will move to the next one: 40 and 42, we wrote that. And then at last 71, 73, and 74, we wrote that. And now see, this data set comes out to be in ascending order, right? We do not had to sort anything in this data. It came out to be ascending order. See, so this is the feature and this is the advantage of writing the data in stem leaf. So if the data is given to us, how can we convert them into a stem plot? Into a stem plot. We saw that how can we acquire the data from the stem plot. Now we will doing the reverse step of it. We will take a data and then convert them into a stem plot. To convert the data into stem plot, first arrange the data in ascending order. See, it was a data, I arranged it into ascending order. Then the simple thing is select the 10th digit. Like see, in the 10th place digit, like here is 1 1 1, then say 2 2 2. The 10th position of the digit, see, it is a ones place, it is 10th place. So 4 7 8 9, these are the 10th place. So we will include them in the stem part. 1 2 3 4 5 7 8, they will be in stem part. 1 is in stem part, then 4 is in also in stem part. And for the leaf, we had written the stem part. Then we will be moving towards the tree part. For the tree part, it is simple. Now as we saw, we written the stem. For the tree part, see, first take the 1 where the 10th position has 1. It is in the three cases. So we will write the stem. Then for the tree, for see the ones place, it here it is 0, so we return 0. For 2, for we return 2, same as for 5. And then we will be moving towards 2. For the 2, there will be 3 and 4 and 4. So 4 is written 2 times, so in stem plot also we will write 4 2 times. Same for 4 7 8 and 9. So we plotted the stem plot of this data. So what was the process? First convert in ascending order. The 10th place will be stem and the ones place will be trees. And that's how we can convert. Or we can also, from stem plot, we can describe the data, which is a easier task relatively, and we will get a sorted data in ascending order mainly. Okay, now we will be seeing graphs. Why the graphs are required? For data analysis, computer doesn't require any graph. It is based on binary, right? So it does not require any graph. But for our interpretation, how can we interpret that data? It is always useful to interpret our data in a visual manner, right? So for our case, the graph is required. We divide the graph into two parts mainly for this week. There will be a scatter plot graph also in week 4, but for this scope of this week, there are two graphs: bar graph and pie chart. Bar graph is usually used when we are comparing things of different groups. Mainly things of different groups, like we are talking about a person who have 6 subject and we have to plot his scores versus the subject in a graph. Then we will be using bar graph rather than pie chart, as they are different groups. Every subject is a different group, right? So in that case, bar graph will be useful. But a person a person studies for 10 hours and want to allot the study time for every subject. as he has only 10 hours, so it will be a single group, right? 10-hour slot is a simple group, a single group, and he wants to divide this group into several subject study time. So when we are comparing different part as a whole, or when we are comparing different parts of a single group, then we will be using pie chart. For the sake of question doing, or for the sake of solving the questions, when the question, in the language of question, the terms are used like ratio, percentage, proportion, or share, then we will be using pie chart. Like it will be saying that what is the share of different things in a grocery store. So as the term share is used, we will be using pie chart in that case. So this can help you a lot, so remember these terms. Then the bar graph is further divided into two types, a simple bar graph and a Pareto chart. Simple bar graph is used for unsequential data and Pareto chart is used for sequential data. The data can be further divided into sequential and unsequential data. A sequential data is basically a sorted data, a data which is sorted either in ascending order or in descending order. But an unsequential data is a random data which is not sorted. So a Pareto chart is used for is a simply bar graph only, but it is of a sorted data, which is usually in most of the cases it is usually arranged in descending order, not in ascending one, because in the descending order the higher priority comes first. Like the most powerful data that has most effect will come first, and therefore the order is important for the Pareto chart. See, here is the Pareto chart. The descending one, which is the highest value, comes first, so it is the vital fews. For example, the 80-20 rule, the according on that rule only. And in this case also, the majority of the things populated by these three only, so they should come first, right? For the sake of arranging the bar graph in ascending order, this vital few will be at last, so we do not want that case. So the vital few comes at the first place, first top places, and then comes useful many. They are useful many, but they are not vital as these three. So we arrange the data in descending order, and we get this Pareto chart. The bar graph is for unsequential. See, no order is here. Now there can be several errors in the graph also. First one is area error. Area error in this width of the graph is not same. See, in this case the width of every bar is not same. Actually, the value of y axis, see, in here the y-axis represent the value of bar chart, but actually the bars in this bar chart, each bar denotes some value of y, right? Every bar denotes the value of y, but actually the length of the bar graph does not depends upon the value of y. Actually it is the area of the bars, area of the bars, which denote the actual value of y. Actually, the area of bars is proportional to the value of y. But we know that area of a triangle is width into height. So, but for every bar in a simple bar chart, for every bar, width is constant, right? See, in this case, every width. See, this is the width. Width is same for each bar, right? As width is same for each bar, width will be constant. Width will be constant. As width is constant, then y is directly proportional to h, that is the height. So we see that more the height, more the value of y. It is in the common case when the width is same. This was the reason basically. But in the area error, the width becomes different for each graph, each bar chart, each bar. So we cannot rely on the height only in this case. In that case, the area principle is violated. Area principle states that the area is directly proportional to the value of y and not the length. So area principle is violated in this case, so it is an area error for bar chart. Now for pie chart, the angle subtended by each things, like for area, there is 360-degree angle, right? 360 is possible in the pie chart, but according to shear this angle is divided. But see, in this graph 50% is contained by dog, but it should take half of the area, which is not the case, so it is an error. And also if we add all the percentages, it is greater than 100%, so it is an area error, whenever the percentage is greater or less than 100, or the share taken by an object is not reflected in its area or its angle subtended, then it will be an area error of pie chart. So this was the difference between pie chart and bar graph area. And there is another error in bar chart called baseline error. The base of the graph must start from 0, and in some cases it's not given, it is not given. See, in this case, it start from 0 but it is not given anywhere. He should write 0 at this place but not written, so it will be a baseline error. So, and whenever there is a abrupt change, see, if it was 3000, and in this case if it was not a 4000 but 70,000 or any abrupt change, we should use a symbol called kink, in this place, to represent that there is an abrupt change and we should be prepared for it. For example, in this bar chart, see, 7 million to 32 million, a very abrupt jump. So a kink is used for the bar graphs also in the y-axis. It can be also on x-axis on also in certain cases, but in this case it is on y-axis. So whenever there is a abrupt change, the kink is used, right? So now we will be seeing some percentile concept of percentile. Uh, a person with for the system of percentile, we can start with simple definition of what is percentile. A person with 90 percentile means he has scored greater than 90% of the participants giving the exam. So if a person scores 90 percentile, it means he has scored more than the 90% of the population giving the exams. In other words, I can say he is in top 10%. Okay. And the basic difference between percentage and percentile is, the percentage is calculated by the marks given by total marks at into 100. Basically it is calculated by dividing the marks by 100, causing a unitary method. But in case of percentile, it is different and mainly useful than percentage in many various cases. For example, take a person who has preparation level of x, right? And he takes two tests. First test was easy and second was relatively very hard. So he scored different marks at different tests, but his preparation level for both the tests were same. So he should score same percentage, right? But the first paper was easy, so he scored greater percentage, and the second was hard, so he scored lesser percentage. So in that case, percentile comes play. Percentile does not depend on the total marks, but rather depend on the relative performance of the participant giving the test, right? As the name suggests, 90% of the participants, not the marks. So it basically depends on the participants. So in this case, as the test was hard, the average marks will also go down. So its percentile will remain same for both the tests. So he can sx access his test scores basically in a more suitable manner in this case. But for the case of percentage, it will be hard to measure basically his performance. So to measure percentile, let's see some percentile system. For example, a student with 10 marks, actually sorry, a student, when there is a class of 10 students and the marks scored by them is 20, right? So the total marks of a given test is 20 and there are 10 students of taking that test. So now the scores of the 10 students are written here. It lies between 2 to 20, right? The least score is 1 and highest is 20. So to get the percentile, to get the see, like we try to find the 25th percentile. A person with 25th percentile means he has scored more than 25% of population. So basically, in a class of 100 student, he will rank at 75th position, as he is above 25% of people. But as the class number were 100, in the total number of students were 100, so 100 minus 25, so he should be at 75th position in his class, who scored only 25 percentile, right? So for 25 percentile, whenever we want to calculate a percentile, we have to arrange the data in ascending order. Likewise, we arrange the data in stem plot also. For this case also, we have to arrange the data in ascending order first. And now as we arrange the data in ascending order, now we will see, we will basically use a unitary method. We want to calculate 25th percentile, so we will divide, or the maximum percentile one can get is 100. The percentile varies from 1 to 100, remember that. So the maximum one can get is 100. It is a basic logic, right? A person with maximum marks will be above everyone, so his percentile will be 100. So in a class of 100, he is above 100 people. This is the basically the meaning of 100 percentile. So the maximum percentile can go is 100. So by unitary method, 25 divided by 100, 25 divided by 100 into 10 into the number of student in the class, right? So we arrange the data in ascending order to find 25 the position of data. In this 10 students, we will calculate by unitary method. 25 by 100 into number of students, that is 10, comes out to be 2.5. So 2.5th position will be of student who scored 25 percentile after arranging the data in ascending order. But 2.5 is not an integer. So in whenever there is a case that and the data comes out to be an non-integer part, so in that case we will round off the data to a higher integer, to a nearest higher integer. In any case, right, see, I have taken example 2.9. If 2.9 comes the case, then we will move to 3. But if 2.1 comes the case, then also we will move to 3. We will not round off to 2. This is a case to remember. Whenever there, after doing the unitary method, the answer comes out to be non-integer, not an integer. In that case, we will round off the data to the nearest integer, to a higher side, not on the lower. Whenever, see, 2.1 should be rounded off to 1, which makes more logical sense. But there is a formula, we will be learning it further. But for the case to remember for now, we should know that 2.1 will be rounded to 3, not to 2. Always to a higher integer, to the nearest one. Okay, so now we took the third position. So third position scored 3 marks, so the person who scored 3 marks will be getting 25th percentile. Similarly, we can calculate 50th percentile. So 50 divided by 100 into the number of students, that is 10. So the fifth position will be the person who scored 50. Similarly, 75 and 100. So basically we divided the percentile that was 100 into 4 parts and name them as quartile system. So we divided the percentile system into 4 parts and divided each and named each part as a quartile. And this system of division of percentiles is known as quartile system. So q1 will represent 25th percentile and also known as first quartile. Similarly, q2 second quartile, and 50th percentile, q3 third quartile, and 75th percentile and q4 as fourth quartile and 100 percentile. So in this case also 7.5 is rounded to 8, not to 7. And these are the positions of data set of these are the positions of the value of q1, q3, or the person who scored 25th percentile in the data set after arranging the data in ascending order. So remember this fact. Now see, we saw that q1 is the at third position after we calculated above. The third position of student scored 3, so 3 is the answer. The person at fifth position scored 7, so 7 is the answer. The person at 8th position scored 15, so 15 is the answer. And person at 10th position who got the maximum marks scored 20, so 20 is the answer for q4. And similarly we calculated for each one. Now comes the IQR, interquartile range. What does it signifies? IQR generally represents and signifies the spread of the data. More the IQR, more the spread. Basically, the formula of IQR is Q3 minus Q1. The thing that we calculated here, third quartile minus first quartile. So in our case, that the example we took, the third quartile comes out to be at 8th position and first quartile came out to be at third position, right? So we took the data, the number of the student who was at 8th position who scored 15, and the person at third position scored 3. So 15 minus 3 is equal to 12. That is the IQR. So what does this IQR signifies? It is useful for calculating the number of outliers in the data. We will see what are outliers just after it. So it is helping in finding us the outlier, and also it signifies the spread of the data, how much the data is spreaded. More the IQR, more the spread. See, there are two graphs. First one has lower spread, so IQR is also low. Second one has higher spread, so IQR is also high. See, basically it is a difference between Q3 and Q1, right? So if the spread will be less, the difference will be less, as Q3 will be more like here and Q1 will be more like here. But in this case, Q3 and Q1 distance is more, so IQR will be larger, so spread will be larger. So this was the basic definition and significance of IQR. Now we will be looking at the outliers, and after it the percentile system will be done, and then we will be looking at the center measure of central tendencies, and then we'll be overing this lecture. And in this next lecture we will be seeing the measures of deviation, and after it our week 2 and 3 will be completed. So let's see the IQR. After the IQR, let's see the basically outliers. What are outliers? So see, outliers. Let's say for this graph we can see the it was a marks graph of 0 to 20. The previous classic example, we took a class of 10 mark 10 students who gave the exam of 20 marks. This is the same example. We saw that the more number of students were between 5 to 15 only, and very less number were 0 and very less 20. So the more the data is concentrated between 5 to 15, but we saw a sudden bump at 0 and sudden bump at 20. So these bumps can in this case is very closer to the data, so they can be not considered outlier for, but for several cases when the graph is tending to 0 but there will be a sudden bump, so it rises and then falls. For that bump is known as outlier basically. So an outlier is in any data in the data set which is very different from other data sets of, or from the more frequent data set. From more frequent data, they will be very larger or very smaller. So there can be two types of outliers. When the no, let's say the marks is concentrated, a test is conducted, and and the marks of the test, the maximum one can score was 100 and minimum one can score was 0. So 0 to 100 is the range of marks. So but the majority of the class scored between actually between 40 to 60, right? 40 to 60 was the major cluster of class who scored the exam score in the examinations. But there are two people who scored 100, and there is a one person who scored 0. So they are generally very away from the main clutter of the marks and data, marks and person graph, right? So they will be known as the outliers of the data. So outliers can be of two type, either very small or either very large. So the zeroth case in this case is first outlier, and second outlier is the 20th case, which is a larger. So outlier can be either very small or either very large. So to calculate outlier, there can be two types of outlier. To calculate first one, the smaller one, the formula is q1 minus 1.5 times the IQR, and for larger one the formula is alpha. Alpha represent the outlier in our case, so remember that alpha can is either less than the minimum number or more than the larger number. See, it is less than the smaller number or more than the larger number. This is the feature of outlier. It should be either very less or either very very large. So it can be shown in the formula also, either less than q1, that is first quartile, minus 1.5 times the IQR interquartile range, or it is larger than the third quartile plus 1.5 times the IQR, the interquartile range. So let's see, we will put the values in these formulas. Like in the first formula, alpha is less than q1 minus 1.5 times the IQR. We know that q1 is 3 for our example, minus 1.5 the IQR we calculated previously was 12. See, So we put it in the value and we got minus 15. So see, minus 15, the alpha should be less than minus 15. Minus 15 already a smaller number, but alpha should also be less than that number also. Then only it will be a outlier for our data. But see, for a paper was conducted between the maximum one can score was 20 and minimum was 0. So a person cannot score less than 0. So it cannot be in our data set. So first outlier is excluded from our data set. To calculate the second outlier, we will use same formula q3. Here in this case will be q3 instead of q1, and instead of subtraction there will be addition. So q3 plus 1.5 times the iqr, and the after solving we get 33. 33 is also not possible, as the maximum score was 20 only. So in our case there will be no outlier, no outlier in our data, as we calculated. But if there is a hypothetical number 35 comes out to be true in our case, but as the maximum was 20 only. But let's say the test was of 40 marks for our case for just a second, and if a person who scored 35, 35 is larger, greater than alpha, right? 33 here in this case, so it would be an outlier. But in our case there is no outlier. And what is the and remember this formula, very important to find the outlier. So we have to, just for the examination purpose, you will be given a data set and will be told to calculate outlier, because for outlier you have to calculate whole quartile system, then iqr, then you will be able to calculate the outlier. So they generally say to calculate outlier only, and they can check your calculating skills of iqr also, right? So what is the significance of outlier? Their major significance is to collect the discrepancy of the data. Consider there is a Google form which I conducted and took data from various students about their marks versus rank data of any exam, and I want to predict something. But many of the students gave wrong marks versus wrong ranks. See, and I made the table and took the data from all the students who filled the Google form. Uh, in the first column fill the marks, in the second column fill the rank, but there will be discrepancies in some of the rows. So to remove them I can use the concept of outliers, and by doing some ml or by computer I will feed the formula of this one. And calculator and computer usually do this by this method only, to find the outlier of for data cleaning in our data science course, which we will be studying diploma level. For data cleaning we generally use this outlier formula only. So it is a very significant portion in our data science course. So the significance of outlier is mainly to remove the discrepancies of the data. So our percentile system is completed. Now we will be seeing the measure of central tendency, and then at last we will end the lecture. So now let's have a look on the measure of central tendencies. So what is basically measure of central tendency? It tell us how much most of the data or population of data set are aligned to center. See, there can be various many types of data. See, uh, for our large data set, there can be as many as a million data. So how much of the data is aligned to a simpler number or simpler section, we can say. For example, in this graph, if we look, most of the data is surrounded at a certain region. See, it is cluttered at certain region, and very minority of the data is spreaded at most of the other places, but majority of them is cluttered at a point. And this point can be anything, it can be 0 or less than 0 or more than 0, it doesn't matter actually. It The fact that matter is more that it should be centrally aligned or cluttered at some point. So more it is cluttered or more it is aligned, more it will be centrally aligned, or more the stiffer curve will be there. For example, in the second curve, the data is spreaded. In this case also the data is not spreaded evenly, but the situation is somewhat more good than the previous one. The data is less centrally aligned. It is quite more spreaded than the first one, and the graph is also broader due to this. So there can be two types of data sets. First one is the when the most of the data is cluttered at a single point or a single interval, whereas in other type of data set the data is more or less actually spreaded. So to measure how much the data is centrally aligned or to centrally centered, basically, to measure this factor, there are three quantities mainly: mean, median, and mode. There are three quantities to measure how much the data is actually cluttered at a certain interval. So there are three quantities: mean, median, and mode. To and there is a equation that combines them, and the equation says as 3 times the median is equal to 2 times the mean plus the mode. The symbols of them is given in here, so we can check from it. And it is a estimation only. See, it is not actually 100% correct. It has some marginal error, and it is mainly for the unevenly distributed and moderately uneven, more like the broader curve we see. For this curve only, the estimation will be true somewhat, and in this case also it will have some marginal error, but this is the only equation we have that combines these three at a single point, right? Now let's see all three of them in detail. First one is mod, which is the easiest one. For a data set, when various data are given various elements of the data like 223 1 3 2 4 7, we will see the highest frequent data, the data which is most frequently occurred. And in our case, 2 is occurred 3 times, so 2 will be the most frequent data. For the second case, 2 has occurred 3 times, but 1 has also occurred 3 times, and both have the highest frequency. So 1 and 2 both are the mod in this case. So the basic definition is that the element which occurs the highest number of time will be the mod of the given data set. Second one comes the median. Median is nothing but arrange the data set into an ascending or descending order. Then the middle one, after sorting, the middle one of the data the middle one element of the data set will give us the median. So see, first step is to arrange the data. For example, we have given the data and we will arrange the data into ascending order. We arrange the data in ascending order. Select the middle number. Select the middle number. In our case, the middle number is 4, and therefore the median will be 4. There is a formula also, which way I will recommend to not to remember, and it is not to remember also. Like, see, the formula is n plus 1 by tooth position. For example, if n is 11, which is the case of our, see, n is the number of element it has. 2 3 1 2 3 4 5 6 7 8 9 10 11. 11 elements are there, so n will be 11. 11 plus 1 by 2, so 12 by 2, that is sixth. That is sixth position. Sixth position is 4 here, so 4 will be the median. This is the formula is telling to us. Now, if in the first case was easier as the number were odd. See, so for when the elements are odd, we can find a single middle one. But in case of even, when the middle there are two middles, there are two middle numbers. In that case, we will simply take the average of the two. In that case, we will take as a step will be more, just to take average of the two, and that average will be our new median. And the formula is simple here also, as in this case the n is 6. N is 6 also. So in this case, n by tooth uh, n by tooth position, so 6 by 2, that is third position, and n plus 2 by tooth position, this is 6 plus 8, 6 plus 2, that is 8, divided by 2, that is 4. So third plus fourth position divided by 2. Third position here is 4. See, at the third position the 4 is given, and and at the fourth position the element 5 is given. So 4 plus 5 divided by 2, that is average of them. It is also 4.5, matches by our first intuition. So this is the formula which we should not remember it. Just remember the fact that we will sort the data, the all the element into ascending or descending order. If the elements are odd, we will take the middle one. If they are even, we will take the average of the two middle ones. That's it. So median and mode are sorted. The majority of the questions are for mean only, so we will looking at the mean. So see, mean or the average, it is the sum of observation divided by total observation. We must have read about this topic in our lower classes also. Sum of observation divided by total observation. By taking an example, see, this is the data from the data set of any data set. These are the elements of the data. So first one we will add all of them. 2 plus 2, this is 2, plus 7 plus 5 plus 1 plus 3, all the observations are added, sum of observation, and the total observation, how much the elements are there. The total number of elements are 6, so 20 by 6, that is 3133 is the average for this case. Now mean for frequent objects. See, in this data set, in this data set there are 6 elements, 1 2 3 4 5 6. It is not an element written by mistake. So see, we can simply add all of them and divide by 6. It will give us a case. But remember, but consider the fact, when there are millions of data of these types, and several of them are frequent, like 2 is the frequency of 2 is 3 here, right? It has occurred 3 times and 5 has occurred 2 times. In that case, when the data are in millions but they are more like frequent, there is a single number that comes around thousands of time, so we will not add it thousands of time, right? So adding 2 3 times simply means 3 into 2, right? Adding 7 one time, it means 7 into 1, right? Adding 5 two times is equivalent to multiplying it by 2, right? So what we are doing, we are taking the observation and multiplying by its frequency. We are taking the observation and multiply by its frequency. We are taking the observation and multiply the frequency that is it has occurred. It will give us the sum of observation, and at the below we will sum up all the frequencies only. See, the number of time they have occurred, 2 has occurred 3 times, 7 occurred 1 time, and 5 has occurred 2 times. If we add all their times of occurrence, they will give us the total number of elements, right? 3 plus 1 plus 2, that is 6. So their number of occurrence, if we add the number of occurrence of each element, then we will get total number of occurrence, that is the total number of observations. So we can add frequency, the summation of frequency here, and multiplying the frequency with the observation and their summation here. So it can be summarized in a simple formula. So first we will make a table for this data, and then we will look the formula for mean. So let's have a look upon the table. Xi is the observation, right? 2 2 given here, 5 is given here, and 7 is given here. It is the observation, and fi is the frequency of that observation. 2 has occurred 3 times in our data, so 3 is given. 5 has occurred 2 times, so 2 is given, and 7 has occurred only 1 time, so 1 is given. And then we will multiply both of them, that will give 6. See, here we were multiplying, so this is the same operation that we are doing here also. We can say it as fi into fi multiplied by xi. So xi is the observation value and fi is the frequency of observation, so we are multiplying both of them. And for 5 into 2 is 10, and 7 into is 1. So at last we were adding all of them, right? So adding is also known as summation. The formula summation is used, and here we will adding all the frequencies, and adding frequency of each observation will give us the frequency of total elements in the data set, and that was the required for the mean, that is total observation. So we can, total observation can be said as the frequency addition of each element. So sigma of fi, that is summation of all the frequencies, will be at denominator, and fixi summation will be at numerator. And after doing this, 33 by 6 comes out to be same as the method we used earlier, the hectic method. Now we can simply do it by this, and it will be much more easier. And in some cases, like in continuous data, we will be given data in intervals. So how can we perform statistical analysis on it? as there can be infinite elements. So we saw for that reason only we took the concept of class mark, the average of that class interval, right? So for this we can take the class mark, and this will be our new xi, the new observation. See, here the observation were discrete, but here they are continuous. So what we took, we take the average of this element, the all the elements, the average of all the number in the elements, and mark it as a representative of that interval. So for the interval 0 to 4, 2 is the representative of that element, of that interval. So 2 will be the class mark. So now 257 will be the xi, like that. 257 here was xi, similarly this will be the xi, and now there will be some frequency, and from the frequency and xi we will calculate the mean. So the additional step was nothing but to from the interval to convert the interval into class mark, and then do the same procedure as we have done here. So the main part is over. Affected by outliers. So see, these are the central tendencies, but if we in a data set, if we add another outlier number, so for example, in our previous example only, test was conducted between the score of 0 to 100, the maximum were between 40 to 60. If a person is suddenly comes with 100 marks, what will be the effect of mean of that class, mode of that class, and median of that class after the person with 100 marks has entered in that class section, right? So see, mean will be most affected, as we directly add that 100 marks. For in the formula of mean we add the sum of the observations taken, right? So we have to add that 100 marks in our observation. So there is a direct addition of that outlier, so mean will be most affected, but mode will not be affected or very least affected. See, mode is nothing but the frequent data, most frequent data, but the definition of outlier says it is a outlier, matlab it is apart from most of the data, most of the cluttered part, right? If the cluttering of the mass is between 40 to 60, then the outlier will be very farther than 60 or very less than 20, right? So this is the basic definition of outlier. So an outlier cannot have the highest frequency, right? If it occurs at more frequent way, then it will not be an outlier, it will shift the whole graph towards the side the marks is. For example, for a class of 0 to 100, the average was between the cluttered marks between was 0 to 60, right? But 20 student come with 90 marks. Consider this fact, 20 student comes with 90 marks, then the graph will be shifted towards 90, right? Then now the cluttering between the marks will be around 40 to 90, not 40 to 60, right? So they are not outliers if they come more frequent, and they violate the definition of outlier if they are frequent more. So mod can never, an outlier can never be mod, that is the most frequent data. So mod is least affected and mean is most affected and median is somewhat affected. As we sort the data with directly, not and the direct in a direct way, the outliers are not included, but they are included in some way. As we arrange the data, the arrangement, the sorting can be different if the outlier comes. So median is mediumly deflected by the outlier, but mean is most affected and mod is least affected. Now for categorical data, we saw that we saw that addition is not possible in categorical data, right? And there the data we divided in the first week was numerical data and categorical data. So in the numerical data, as they are number, they can be added, right? But categorical data are not numbers, so they can't be added. But for mean we need the sum of observation, but as we cannot perform the arithmetic operation of addition, so how can we find the mean of it, right? So mean is not possible for categorical data. But for the for then we look at the scales of measurement. In week 1 only, the last slide was of scales of measurement, and we saw at that place that nominal and ordinal scales come under the categorical data, and the last two scale, ratio and interval scale, come under the numerical data. So for the categorical data, the nominal scale doesn't have any order also. Nominal scale had no order, right? But to find the median, we have to sort the data first, right? But there is no order, then how can we sort the data? There should be an order, then only we can arrange the data, right, in that order. So as there is no order, so median is also not possible, so only mod is possible. And why mod is possible? It is nothing but most frequent data, so we do not need any addition or do not need any order also, so mod is possible. In ordinal data, as there is an order, so median and mod both are possible, but mean is not possible for any of these, and actually not for categorical data also. So mean is not possible, but mode and median is possible for ordinal data, and mod is possible only for nominal data. Okay, now it's the last part in the topic of measure of central tendency, that is effect of arithmetic operation on mean. And see, here we is I have talked about mean, but these cases are same for median and mod also. See, I have written there, same operation can be done on median and mod, and same result will be seen as in case of mean, as we will see in the mean case. Same cases will be seen in the here also, but I have specifically mentioned mean in here because in the test they mostly ask about mean only. They will be not be asking about median or mode, but still we can remember this fact in case they ask. So first, the addition, and the rule will be same for subtraction also, so remember it. We will be looking for addition and replicate the rule for subtraction also. Similarly, we will be looking at for multiplication, and same will be replicated for division also. So let's see. Consider x1, x2, x3 till xn, and they are the observations. Let's see, for example, this data set, and first one we can say 2 as x1, 2 as x2, 2 as x3, then 7 as x4, then 5 as x5, and 5 as x6. So this is the fact that it is representing. So for this observation, if the mean comes out to be mu, and it is a symbol called mu. If the mean comes out to be mu, and if we add k, a constant can be any number, 1 2 3, any number. If we add any number to each of the observation, like first when the observation was 1 2 3 till n, and the median comes out to be 7, then we added 2 to each element, 1 plus 2, 2 plus 2, 3 plus 2 till n plus 2. Then mean, in the mean also we will have to add 2 only. So if we add a k to each element, then mean gets also added by k. So in our example, if we add 2 in each case, then mean will be also added by 2. So the new mean will be 7 plus 2, that is 9. This was the first case for addition, and same will be applicable for subtraction also. For multiplication, if same x1 x2 xn, the mean is mu, so 1 2 3 till n, the mean is 7. If we add a constant, the constant can be any number, l l can be 1 2 3, any number. So if we multiply by each observation by this constant, or divide by this constant, division, it is same for division. Let's see for multiplication only for this case. If we multiply by 2, 2 in each case, 1 is multiplied by 2, 2 is multiplied by 2, 3 is multiplied by 2, and n is also multiplied by 2. Then mean will also be get multiplied by 2, so new mean will be 7 into 2, that is 14. This is to be remembered, mu plus k. And second one, if we multiply each element by l, then mean will also be multiplied by l. And it is, and both the cases, addition and multiplication, are true for median and mode also, which I have told earlier. Let's see and question about this arithmetic operation, so we can get our facts clear. uh, in this question, mean of the data is 3. Find the new mean if 2 is multiplied. If 2 is multiplied, then 4 is added to each element of the data set. So first, for the element in data set, the mean was 3. Then we multiplied each element of the data set by 2, and at last we added 4. We added 4 to each element of the data set. Then what will be the new mean? First the mean was 3. After multiplication with each element with 2, the mean will also be multiplied by 2, so the new mean will be 6. And at last we added 4 to each element, so after addition, mean will also be get added by 4, so 6 was the new mean. Then we added 4 to it, so 10 will be our newest mean. So the latest mean is 10 in this case, and this is the answer for our question. And this is the last topic, that is measure of deviation. It is the only harder part of this thing is the formulas, the two formulas which are relatively easier only, but let's see them. What is deviation? The measure of deviation. What is the measure of deviation? It is the fact that how much the data is deviated from the center. It is directly opposite to the first fact that we saw, that measure of central tendency. It is the opposite of measure of central tendency. In the measure of central tendency, we saw that how much the data is cluttered. The more the data will be cluttered, more the value of mean, median, and mode. Remember this fact, that as mean, median, and mode are the representatives of the measure of central tendency, more their value, more will be the data cluttered at a certain point. But more the data is spreaded, more will be the deviation, right? If the data is centered at a certain point, the deviation will be very low. But if the data is more spreaded, that then the deviation will be larger. So they are directly opposite to the measure of central tendencies, and they also have three factors that define the measure of deviation. First one is range, second one is variance, and the last one is standard deviation. And note, all three, like mean, median, mode, were affected by outliers. They also, all three are affected by outliers, and the extent they affected by the outliers is not in the scope of our syllabus, but we have to remember that they are affected by outliers. First one is range. Range is the easier than mode also. See, range is nothing but maximum value minus minimum value. For this data set, the maximum is 11 and the minimum is 1. So range will be 11 minus 1, that is 10. That's it. So how it is representing the deviation? See, more the value of range, more will be the difference between maximum and minimum value. So see, in this case, the minimum, as the data is cluttered at a certain point, so as there is a cluttering, the difference will be between them. See, the width of this can be represented by range. The width of the graph here is very shorter, but here the graph is broader, the width will also be broader. So the range directly represents how much the data is spreaded in the extremes. So more the range, more the data is spreaded. Second one is variance. See, what does the variance signifies first? Let's see the formula of variance first. The formula which we'll be generally using is this, and for some cases this is the formula which we'll be studying this part only in 2 minutes. Let's see the first formula first. It is the xi. We saw x1, x2, x3, the number of all the observation. Xi minus mean, it means the difference of certain number from mean. What does mean signified at the first place? Mean that we studied was under the measure of central tendency, right? So mean represented a central value. Let's see. In our first case, when we saw the measure of central tendency, we read about mean, median, and mode, right? So what does mean signifies? Mean actually signifies how much the data is at the center, right? As it is a measure of central tendency. So anything minus mean will represent how much there is a difference between a point xi minus mean. So xi, how much the difference of xi from the center, right? How much it is deviated from the center. If mean represent the center, anything minus mean will represent how much it is deviated from the center. So indirectly it measures the deviation only. But consider a fact. So let's see this definition, and let's tells about the deviation from mean, that is denote the deviation from the center. You understood the fact that as it is deviation from mean, as it is subtracting from mean, so it is a deviation from the mean. So and as we know, the mean represent the measure of central tendency, so it is a deviation from the center. So the variance represent nothing but the deviation from the center, hence it is a measure of deviation. So for population, and why we took the square here? See, if in case the first one the deviations comes out to be 3. First one the mean was lower and xi was greater, the mean came out to be 3. If we not take the square, and the second deviation comes out to be minus 3, the net deviation will be adding all the deviation, but here as it is a minus 3, the net deviation will be 0. But we know that at first place our data point was on left side, so there will was some negative deviation as the data was here only. But when the data come out to here, there was a positive deviation. but it is telling the net deviation is 0, but it is not the case. We have deviated at different directions. What does this minus signifies? It signifies the direction of deviation, on which side the deviation is occurring. For example, in the graph here, if the data is located here, the more centrally aligned data is here. If our data, if our data lies here only, then this will be our deviation of d. But if the data is represented here only, so it will also represent d. Let's say d1, let's say d2, but d1 will be negative, as it the data is on left side, it is on negative scale, so d1 will be negative and d2 will be positive. But when we add them all, the deviation, the net deviation will be d1 minus d2, not d1 d plus d2, as there will be a negative sign due to d1. But we know that it gives us a false assumption that the deviation is lower, but we see that a data is we should add them only, we should add the data, not subtract the data. So to get away from this concept, so to solve this problem, we squared each object, we squared each term, so it will give only a positive value. So 3 square minus 3 square, that is 18, so we got a maximum deviation possible. So for this is the formula, just remember it. We will take example to analyze this formula. Xi minus mean whole square, and we will take the summation of this divided by n. For sample, it is for population. For sample, there is a Basel correction. Instead of n, that is number of observation, we take n minus 1. It is Basel's correction, nothing much. Actually, when we take sample and we will be moved to population, these values, the value of variance, as we knew in the descriptive inferential statics of week 1, we take sample, we take data of sample only, and then we transfer that data into the population with some probability of correction, right? So when we saw that we took the data from sample and transfer to population, the value becomes slightly lower, slightly the value of variance slightly decreases. So to overcome that thing, we added Basel's correction, that is just minus the observation number of observation by 1, which gives 10, tends to minimizes the error only. This was the basic reason. So we understood variance, it is the how much there is a difference from the central tendency or from the mean, and this is the variation, and it gives the difference or the deviation from the mean. And just take root of this thing. If we take root of this thing, then comes the third part, the standard deviation. It is nothing but root of the variance. See, here we took the square in order to maximize the deviation, right? We saw that if the deviation was on left side, it came out to be minus, and if the deviation was on right side, it came out to be positive. But when we wanted to get the net deviation, we had to add both of the deviations. But as due to this negative just signifies that it was on left side, but on the process of addition we got 0. So should we say that there is no deviation? It is completely wrong. There was deviation, that's why this d1 and d2 came. So to avoid that confusion, we squared both terms, and then we got some maximum deviation possible. But see, this is actually furthermore greater than the deviation we actually thought. As we took the square, we should also take root also, na, to compensate that square. So it was not compensated at the variance. So to compensate, in order to compensate that, we took the square root of that variance. So it is represented by sigma square, and standard deviation is simply represented by sigma square over root. So it is represented by sigma only. So as it is under a square root, and remember this fact, as standard deviation is under square root, it is under square root, right? So it can never be negative, else it will be a complex number. As a real number, anything inside the square must always be positive, so it should always be positive, it should can never be negatives. And same for variance also. Any number squared, if we square minus 2, then comes 4. If we square 2, then also come 4. So whether the number is negative or positive, when it is squared, it comes out to be positive. So variance that is the square of the deviation, it will always become positive. And as the as a variance is positive and it is under root, so anything under root must be positive. So in short, the thing I wanted to say is the fact that variance and standard deviation both will always be positive, and the formula is same as variance. Just take root over it and we will get the formula. And same for population, it is n, for sample is n minus 1. Let's see same effect of arithmetic operation on both of them. We represent r for range and sigma for standard deviation and sigma square for variance. If we add anything in the observations, then r and range and standard deviation, both of them will not be affected on addition or subtraction. Remember this fact. range and mm, Range and standard deviation both are unaffected by the effect of addition, but by multiplication, a number, if we multiply a constant L as we multiplied in the mean, then they will also be multiplied by L. So they are affected by multiplication. The range and standard deviation both are affected by the multiplication, but are not affected by addition or subtraction. Now for variance also, for addition no effect is seen, but for multiplication, if we multiply it by L, and then it will get, the variance will get multiplied by L square, not by L but by L square. And it is like obvious, like see, the standard deviation, when we multiplied each observation by L, the standard deviation was multiplied by L, right? But what is variance? Variance is nothing. See, what is variance? Variance is nothing but sigma square, that is standard deviation ka square. So if we multiply the standard deviation with L, then it will be squared. So the new variance will be multiplied by L square only. So this is the case. It is multiplied by L square. So this was the case. The effect of arithmetic on range, standard deviation, and variance. For examination point of view, the multiplication or addition or anything arithmetic operation on range will not be asked. Only standard deviation and variance is asked for, the but the formula for range is similar to standard deviation, so I thought to memorize you guys. Now take an example. It is the last part of our week 2 and 3. We will take an example. We will try to solve how to calculate the variance of and standard deviation. Let's see by example. We will be doing questions in next class, but for the theory class as we are concerned, we will looking at this example only. See, there is a class interval and we have to find the variance from it. So first step will be, it is divided into steps and I have written each and every step. First step will be to calculate class mark from interval. We should calculate the class mark. 10 to 20 the average is 15, 20 to 30 the average is 25. This is the first step. We calculate all the class mark. They see, it is the third process. So where is the second process? Second process is here. After calculating the class mark, we have to see, it is a formula, it is the formula for variance, right? So to calculate sigma square and sigma, we have to calculate mean first. The difference of mean is taken, na, right? Observation is, we know what is the observation. 1 2 3 4 5, 5 observations are there. We know n, we know xi is nothing but it is x1, it is x2, x3 is 35, x4 is 45, and x5 is 55. This is the xi. The fact that we don't know is mean, so we calculated the mean. After calculating the class mark, as they are infinite values, we converted into class mark, and then we calculated the average of that class mark, summation divided by frequency, and then 35 came out to be the class mark. Now we will take the deviation, xi minus mean. See, here is the xi minus mean, that is the deviation. First, the deviation, see, deviation is nothing but 15 minus the mean, that is 35. 35 is the mean, right? We calculated it here, we calculated the mean. So 35 minus 15 minus 35. Actually, let me see this, for a while. Okay, okay. Actually, is the wrong data. Let me see. uh, I have to. The summation should come 125, I guess. And the summation should come 125. And the mean that is the answer will not be 35 actually. It will be 25. So let's see. It will be 25 instead of 35. Now it will be cleared. See, now we want to take the deviation, so xi minus mean. So xi is there 15, minus mean was 25, so minus 10 comes out to be deviation. So minus 35, sorry, minus 25. So 0 comes out to be the deviation. Here minus 25 10, minus 25 20, and minus 25 30. See here, the deviation is minus 10 and here deviation is 10. If we simply add these deviations, they will be cut it out. But does that mean that it is not a deviation? It is not a deviation. They both are deviation. So there should be a fact that should separate them. If we directly add them, they cut each other. So we do not want that case. See, it was also a deviation, but the fact that the number was smaller than mu doesn't mean that it is not a deviation. So if we directly add them, they will be cleared out. That's why we take the squares. It is the importance of the square. If we take square of them, they see both are positive. Now we can simply add them. So we added minus 10 square 100, 0 square 0, 10 square 100, to 20 square 400, and 30 square 900. So this data comes out to be, and then we add them. See, sigma is given. Sigma is given, so we add 100 zeros, 100, 400, and 900. And we see in the question, find sigma and sigma square for sample data, not for population data, but for sample data. If nothing is given, see, remember this fact. If nothing is given, we will be calculating data for population, and n minus 1 will not be there. Simply n will be written by us in that question. But here it is specifically saying about the sample data. Okay, if it is saying about sample data specifically, then we will do n minus 1. So 5 minus 1, so 375 came out to be the answer of variance. Now we will take the square root of 375, so 19.36 will be the standard deviation. So we calculated variance and standard deviation for both of them. See what was marked at what marked the deviation. First, it marked the deviation out to be minus 10. Xi minus mu. Xi, that is xi can be start from 1, it can be 2, it can be 3, anything. So 15 minus 25 came out to be minus 10. Similarly, if 25 minus 25 came out to be 0. So the deviation from the mean, that is deviation from the center, as mean represent the center, is the deviation actually. And the deviation can be negative and positive. To avoid that confusion, if we cannot directly add them, in that case the deviation cast and gets cutted out. We do not want that case, so we square both or each term and then we add. After adding, we divide by n, and but in the sample data we divide by n minus 1, and we get the variance. And we just need to under root that, put that variance under root, and we get the standard deviation. So more the value of c, more the value of mean, median, and mode, more the data is centrally aligned, right? And similarly for these also, more the value of variance, standard deviation, and range, more will be the data spread it out. Remember this fact. So this marks the end of week 2 and 3, and in the later classes we will be taking doubts in any of the lecture we have faced so far. And also the questions, a lot of question will be there, and after doing the questions only we can understand these fact also. You guys may have some confusions in your mind, which is naturally clear, and it will be cleared only after doing questions. So we will be doing question in next class. So and fourth week will be our last week. So let's end the class then.